In this video, I'm going to go through the solutions to my 2024 practice paper, and this one's for AQA Paper 1 Higher. Before going through this video though, I'd highly recommend you try the paper for yourself. You can get a free copy of this at my website, firstclassmaths.com. I'll also put a link in this video's description. To write this paper, I've done some detailed analysis on how often each topic has come up in past papers. For this one, I've specifically looked at the topics that appear most frequently in Paper 1. So those topics with the highest percentage will make up the majority of this paper. This doesn't mean though that these topics are guaranteed to appear. The best way to prepare for your exams is to revise all of the topics. So now we're ready to have a look at the solutions, and we're going to begin with question 1. In this question, we need to write 0.00037 in standard form. When we write a number in standard form, we're first of all looking for a number between 1 and 10. Looking at the digits we have in this question, that number is going to be 3.7. Then we're going to multiply this by a power of 10. We just need to work out what that power is going to be. Now, since this number is a small number, we're going to consider what happens when you divide it by powers of 10 first. So let's take 3.7 and divide it by 10, which is 0.37. That's not the number in the question, so we're going to keep dividing by higher powers of 10. So 3.7 divided by 10 squared instead. 10 squared is 100, and 3.7 divided by 100 is 0.037. This is also not the number we're after, so we go again. This time divide by 10 to the power 3, that's 0.0037, and we need to go one more time, 3.7 divided by 10 to the power 4, which is 0.00037. So our number is the same as 3.7 divided by 10 to the power 4, but we need to write standard form using a multiply instead. So it will be 3.7 times 10, but rather than the power 4, the power negative 4. And that's the answer to this question. In this second question, we need to solve an equation, and it's been given to us in a factorized form. Since we have two brackets multiplied together that must give 0, then either the first bracket will be 0, so c plus 4 must be 0, or the second bracket must be 0, so c plus 3 must be 0. Let's take these two equations and solve them. If c plus 4 equals 0, we can subtract 4 from both sides. If we subtract it from the left, the 4's will cancel, so we have c, and on the right hand side, 0 take away 4 is negative 4. If we do a similar idea for the right equation here, subtract 3 from both sides, then we get c equals negative 3. So there are two solutions to this equation, c equals negative 4 and c equals negative 3. In this question, we need to find the gradient of a line. When we write an equation in the form y equals mx plus c, the m, which is the number before the x, is the gradient. So we want to rewrite this one in the form y equals mx plus c. We can simply just rewrite it as y equals negative 4x plus 3. You can now see the value of m, which is this negative 4 here, which is the gradient. So the gradient of this line is negative 4. In this question, we've been told that shape A is enlarged by scale factor 4 to give shape B, but we need to work out the scale factor of enlargement from shape B back to shape A. So let's take a shape and call it A, and imagine we enlarge it by scale factor 4. This means all of the lengths of the shape will be 4 times as big, so it will look something like this, and that's shape B. So to get from shape A to shape B, we multiply all of the lengths by 4. We need to work out what we multiply the lengths of B by to get back to shape A. Well, the lengths of shape A will be 1/4 of the size of those of shape B, so the scale factor will be 1/4. So the answer to this question is 1/4, and you could write this as a decimal if you wanted, 0.25. In this question, we need to write negative 3a as a column vector. To do this, we're first of all going to work out the vector for A. To do this, I'm going to put a cross at each end of this vector, and we're going to consider how we get from the cross in the top right to the one in the bottom left, since that's the direction the arrow is going. To get from the cross in the top right to the bottom left, I need to go 5 to the left, and then I need to go 1 down. So we can write the vector for A as negative 5 since we went left, and negative 1 since we went down. The question has asked us to find the vector for negative 3a. To do this, we just multiply the numbers in the vector for A by negative 3. So we start with negative 5 multiplied by negative 3, which is a positive 15, and negative 1 multiplied by negative 3, which is positive 3. So the answer to this question is the vector 15, 3. In this question, we've been asked to give the answer as a fraction. So we have 1.5 squared here, which is a decimal, so I'm going to rewrite that as a fraction first. 1.5 is the same as 3 divided by 2, so we could write this as a fraction as 3 over 2. And then we need to multiply this by 1/3. To do 3 over 2 squared, you'll multiply 3 and 3, which gives you 9, and 2 and 2, which gives you 4. So we end up with 9 over 4 multiplied by 1/3. To multiply fractions, you multiply the numerators, then multiply the denominators. So we do 9 times 1, which is 9, and on the bottom 4 times 3, which is 12. Now you could actually leave this as the answer to this question since it hasn't asked us to simplify, but I expect many of you will have simplified. If you divide both of these by 3, you get 3 over 4. In this question, we've been told about two semicircles, and the area of one of those is 18 pi centimeters squared. So let's take a semicircle, and its area is 18 pi. Now if we draw the other semicircle on, this one must also have an area of 18 pi, since they're the same shape. This means the area of the entire circle will be two lots of 18 pi, which is 36 pi. So we know the area of this entire circle is 36 pi. To calculate the area of a circle, we use the formula pi r squared. So for this circle, we know that pi r squared must equal 36 pi. You can divide both sides of this by pi to give you r squared equals 36. You can then find the value of r by square rooting both sides, and you'll find that r is 6, since 6 times 6 is 36. So now that we know the radius of the circle is 6, we're able to find the circumference like it asks us to in the question. To find the circumference, you use the formula circumference equals pi times diameter. The diameter of this circle must be double the radius, and the radius is 6, so the diameter must be 12. So to find the circumference of this circle, we do pi multiplied by the diameter, which is 12, and in terms of pi, this is just 12 pi. In this question, we need to complete a table of values. To do this, we're going to substitute all of our x values into this equation here to work out the corresponding y values. We're going to start with when x equals negative 3. So if x is negative 3, we need to do x, which is negative 3, and then inside this bracket we've got x squared, so negative 3 squared, subtract 4. To work this out, we're going to write negative 3 and then this bracket, and then we'll work out what's inside the bracket first. Inside this bracket we have negative 3 all squared, which means negative 3 multiplied by itself, which is positive 9, and then take away 4. We can do 9 take away 4, that's just 5, so this is negative 3 multiplied by 5, which is negative 15. So when x is negative 3, y is negative 15. We then do this same process for all of the other values. So let's go for when x equals negative 2, we have negative 2 multiplied by, in a bracket, negative 2 squared, subtract 4. We'll work on what's inside the bracket again, so we have negative 2 lots of, negative 2 squared is a positive 4, and take away 4. Well, 4 take away 4 is 0, so we have negative 2 multiplied by 0, which is 0. So when x is negative 2, y will be 0. Then we move on to x is negative 1, so we have negative 1 lots of negative 1 squared, subtract 4. We'll work on what's inside the bracket. Negative 1 squared is positive 1, take away 4. And 1 take away 4 is negative 3, so we've got negative 1 multiplied by negative 3, which is positive 3. So when x is negative 1, y is positive 3. Finally, we'll do when x is positive 2. Here we have two lots of 2 squared, subtract 4. 2 squared is equal to 4, so we end up with 4 take away 4, which is 0, so we have two lots of 0, which is also 0. So when x is 2, y is 0. For the second part of the question, we need to draw the graph of this equation. To do this, we'll use the table of values. So the first point is when x is negative 3 and y is negative 15. If we were to plot that, that would go at negative 3, negative 15, which is here. Then we do negative 2, 0, which goes here, negative 1, 3, which goes here, 0, 0, which goes here, 1, negative 3, 2, 0, and 3, 15. Then we join up these points with a nice smooth curve. This one will look something like this. In this question, we've been asked to work out the number of red counters in the bag. We've been told some information. The number of green counters is 15 more than the number of red counters, and the number of yellow counters is 4 more than the number of green counters. So let's say the number of red counters, the thing we're trying to find, is equal to x. Then the number of green counters is 15 more than this, so the number of green counters must be x plus 15. The number of yellow counters is 4 more than the number of green counters, so we can add 4 to x plus 15, which gives us the number of yellow counters at x plus 19. So we now know there are x red counters, x plus 15 green counters, and x plus 19 yellow counters. To get the total number of counters in the bag, we would just add all of these together. So x plus 15 plus x plus 19. We can simplify this a little. So if we add together all of the x's, we've got x, which is 3x. And then 15 plus 19 gives you positive 34. So in total in the bag, there are 3x plus 34 counters. We've been told that 1/5 of the counters in the bag are red. So if we take the total number of counters and divide it by 5, this must give us the total number of red counters, which we called x. So this must be equal to x. And now we just have an equation to solve. To solve this equation, I'm going to multiply both sides by 5. If I multiply the left-hand side by 5, that'll cancel the divide 5 that's already there. So I'll have 3x plus 34. On the right-hand side, x multiplied by 5 is 5x. Then we could subtract 3x from both sides. If we subtract it from the left-hand side, it will cancel with the 3x that's already there, so we have 34. And on the right-hand side, 5x take away 3x is 2x. And finally, we divide both sides by 2. On the left-hand side, 34 divided by 2 is 17, and 2x divided by 2 is 1x. So we found that x is equal to 17, but remember, x was the number of red counters, which is what we were trying to find. So the answer to this question is 17. In this question, we've been told the volume of a cube, which is 8x to the power 6. So let's take a cube and imagine how we find its volume. To find the volume of a cube, you multiply the length by the width by the height. But for a cube, these are all the same. So to find the length of this cube, we could take the volume, which is 8x to the power 6, and do the cube root of it. To do the cube root of this, we'll do the cube root of 8 first, which is 2, since 2 multiplied by 2 multiplied by 2 gives you 8, and then x to the power 2, since x to the power 2 multiplied by itself is x to the power 4, and multiplied by itself one more time is x to the power 6. So all of the lengths of this cube must be 2x squared. Now we've been asked to work out the surface area of this cube, so let's work out the area of this face here first. To do the area of this face, we'd multiply the base by the height. Both of those are 2x squared, so we do 2x squared multiplied by 2x squared. 2 times 2 is 4, and x squared times x squared is x to the power 4, so we end up with 4x to the power 4. So the area of one of these faces is 4x to the power 4. But since it's a cube, all of the faces have the same area, and there are 6 of them, so we can take 4x to the power 4 and multiply it by 6. You just do 4 times 6 here, which is 24, so we have 24x to the power 4. And that's the answer to this question. In this question, we've been told that between Monday and Tuesday, the temperature has increased by 10%. So we're going to say the temperature on Monday is going to be equal to T. The temperature on Tuesday then is 10% more than this. So to work out the temperature on Tuesday, we'll take the temperature on Monday, which was T, and multiply it by the multiplier for a 10% increase. To work out the multiplier for a 10% increase, you take 100% and add 10% to it, which is 110%, and then divide this by 100, which is 1.1. So a multiplier for a 10% increase is 1.1. So we could multiply the temperature on Tuesday by 1.1, which is the same as 1.1 T. Now if we move on to the temperature for Wednesday, between Tuesday and Wednesday, it decreased by 20%. So to find the temperature on Wednesday, we take the temperature on Tuesday, which was 1.1 T, and we're going to multiply it by a multiplier that corresponds to a 20% decrease. For a 20% decrease, you start with 100%, but subtract 20%, which is 80%, and then divide 80 by 100, which gives you 0.8. So the multiplier for a 20% decrease is 0.8. So we'll multiply 1.1 T by 0.8. To do this, you can multiply 1.1 and 0.8, which is 0.88. So it's 0.88 T. We're now told that between Monday and Wednesday, the temperature has decreased by X%. Well, on Monday, the temperature was T, and on Wednesday, it's 0.88 T. So we just need to work out what percentage this multiplier corresponds to as a decrease. Well, since it's 0.88, it's reduced to 88% of its original value. If the original value was 100%, then we do 100% subtract 88% to realize we've lost 12%. So the answer to this question is x is 12%. In this question, we have a geometric progression, and we need to work out the value of the third term. When we have a geometric progression, to get from one term to the next, you're going to multiply by some constant number. So we need to work out what that number is. To do that, we can take the second term and divide it by the first term. So 3/10 divide by 3/4. When you divide fractions, you can keep the first one the same, but then multiply by the reciprocal of the second one, which is like flipping the fraction upside down. So we multiply by 4 over 3 rather than 3 over 4. Now we can just multiply the numerators. 3 times 4 is 12, and the denominators 10 times 3 is 30. This fraction will actually simplify. If you divide both of them by 6, you'll end up with 2 over 5. So to get from 3/4 to 3 over 10, we multiply by 2 over 5. This will be the same for all of the terms of the geometric progression, so to get from 3/10 to the third term, we also multiply by 2 over 5. So all we need to do now is take 3/10 and multiply it by 2 over 5. To do this, we multiply 3 and 2, which gives you 6, and then 10 and 5, which gives you 50. This one will also simplify. You can divide them both by 2, and that will give you 3 over 25. So the answer to this question is 3 over 25, or as a decimal, 0.12. For part A of this question, we need to complete the cumulative frequency table. The first value in the cumulative frequency table will be the same as the regular frequency table, so we take this value here, a 3, and put that here. For the next part of the cumulative frequency table though, we're looking at all of the times that go up to 90 minutes. So we need to include the 3 times from 0 to 45, but then these 9 times here from 45 to 90. That's a total of 12 times, so 12 goes in here. For the next entry, we need to go all the way up to 135, so we now need to include these ones. If you add 3 and 9 and 18, you get 30. Then for the final one, all the way up to 180, so we need to include these 6 as well. And if you add those 6 in, you get 36. For the second part, we need to use this information to draw a cumulative frequency graph. To do this, we look at the first entry in the cumulative frequency table, and we plot the endpoint of that interval, which is 45, with the cumulative frequency of 3. So at 45 on the time axis, we go up to a cumulative frequency of 3, so we put a cross about here. The endpoint of the next interval is at 90 with a cumulative frequency of 12, so at 90 we plot a cumulative frequency of 12. For the next one, we need to go up to 135 and 30, so that one goes about here. And for the final one, it's 180 and 36, which goes here. We then join all of these up with straight lines, and we end up with a cumulative frequency graph that looks like this. You're also allowed to join these up with a nice smooth curve, but I always recommend doing straight lines because you still get the marks, and personally, I find it easier to do. In this question, we're told about Jess and her collection of trading cards. She has 5 rare cards, 8 uncommon cards, and many common cards. And she's going to give one of each of those types of cards to her friend. Jess says that there are 1,100 different ways of selecting these 3 cards, and we need to show that Jess must be incorrect. So to work out the number of ways of selecting these cards, we take the number of ways of picking a rare card, which is 5, we multiply this by the number of ways of selecting an uncommon card, which is 8, and then we multiply this by the number of ways of selecting a common card. Now, since we don't know how many common cards there are, we're going to call this C, so multiplied by C. And Jess is proposing this gives the answer 1,100. On the left-hand side here, if we multiply 5 and 8, we get 40, and 40 multiplied by C is just 40C. So Jess is saying that 40C will be equal to 1,100. If we divide both sides of this by 10, on the left, 40C divided by 10 is just 4C, and on the right, 1,100 divided by 10 is 110. We can then take this equation and divide both sides by 4. 4C divided by 4 is 1C, and 110 divided by 4 is 27.5. Now remember, C is the number of common cards in the collection. So if Jess is correct, there must be 27.5 common cards. The number of common cards must be an integer, so we can't have 27.5 common cards. So we've now shown that Jess must be incorrect, and we could write a concluding statement: the number of common cards must be an integer. In this question, we've been asked to work out the interquartile range of the race times. To do this, we need to do the upper quartile subtract the lower quartile. We can find the upper quartile from looking at the right-hand side of this box on the box plot. The upper quartile will be at 58, and the lower quartile will be the left-hand side of the box on the box plot, and that's at 22. So to find the interquartile range, we subtract these. 58 subtract 22 gives you 36. For this question, we've been given 2 inequalities, one for x and one for y. In the first part of this question, we've been asked to represent the inequality for 2x onto the number line. So let's look at the inequality for x over here. This shows us that x must take values in between 1 and 4, and it can be equal to 1 because we have a shaded circle, but it can't actually be equal to 4 because the circle is open. Now if we're going to do 2x, the lowest possible value of this must be double the lowest possible value for x. So the lowest possible value of x is 1, and if we double that we get 2. So the lowest possible value of 2x is 2. Then what about the highest possible value for 2x? Well, remember x can be any number up to 4 but not actually equal to 4. And if we double 4 we get 8. So x can be any number up to 8, but it can't actually be 8. So we draw an open circle at 8, and then connect these up with a line. For the second part of the question, we're looking for the inequality of x plus y. To find the lowest possible value for x plus y, we take the lowest possible value for x, which is 1, and add to it the lowest possible value of y, which is 3. 1 plus 3 is 4, so we need a circle at 4. Since x can actually be equal to 1 and y can actually be equal to 3, x plus y can be equal to 4, so we use a shaded circle. For the maximum possible value of x plus y, we take the maximum value of x, which was 4, and add to it the maximum value of y, which is 6. 4 plus 6 is 10. So we're going to draw a circle at 10. Now on the y inequality, we have a shaded circle, which means y could have actually been equal to 6, but unfortunately x can't be equal to 4, it can be any number up to 4. So we can't actually get 10, so we're going to do an open circle at 10 to represent the fact that we can have any number up to 10. We then connect these up with a line, and that's your answer to the question. In this question we have two lines, L1 and L2, and we know they intersect at a point A. We know the x-coordinate of that point A, which is 15, and we need to work out the y-coordinate. To do this, we're going to use the second equation here, L2. So let's take that equation, and since we know the x-coordinate of the point A is 15, we can substitute x for 15. So instead of 2x, it's 2 lots of 15. And then subtract 3y equals 36. 2 lots of 15 is 30, so it's 30 subtract 3y equals 36. This is just an equation to solve. Subtract 30 from both sides. On the left, we'll end up with negative 3y, and on the right, 36 take 30 is 6. Then we can divide both sides by negative 3. On the left, this will give you y, and on the right, 6 divided by negative 3 is negative 2. So the answer for the y-coordinate is negative 2. For the second part of this question, we need to work out the value of k. This time, we need the first equation. So let's take that equation, and just like before, we know the x-coordinate of a is 15, so let's replace x with 15. But in the first part of this question, we worked out the y-coordinate was negative 2. So let's also replace the y with negative 2, and this equals k. 2 lots of 15 are 30, and 5 times negative 2 is negative 10. So 30 take away 10 equals k. 30 take away 10 is 20, so the value of k must be 20. In this question, we have the recurring decimal 3.51 recurring, which we need to write as a fraction. To do a question like this, we say that x is going to be equal to 3.51 recurring, which is 3.515151, and so on. Then we multiply this by 10. If we multiply x by 10, we get 10x. If we multiply 3.515151 and so on by 10, we get 35.151515, and so on. Notice all of the digits have just moved one place to the left. At this point, we want to check if all of the numbers after this decimal point line up, and you can see here that we have a 1 and a 5, so they don't line up, in which case we're going to multiply by 10 again. So if we multiply 10x by 10, we now have 100x. So we move all of these digits one place to the left, so it'll be 351.515151, and so on. Now if we do this check again to see if we've got any numbers that line up perfectly, you can see here this 51515151 lines up with this 51515151. This means we found the two numbers that we need to subtract. It's 100x and 1x. So if we write out a subtraction and we do 100x subtract 1x, we get 99x. And this equals those numbers subtracted. So 351 subtract 3, which is 348. Then if we go for the numbers after this decimal point, the 515151 and so on, subtract 515151 and so on, will just give you zeros. And 348.00000 and so on is just 348. So we find that 99x must equal 348. We can divide both sides of this by 99. 99x divided by 99 is 1x, and 348 divided by 99 is just 348 over 99. This question asks for the answer to be in its simplest form, so we can simplify both of these by dividing by 3. 348 divided by 3 is 116, and 99 divided by 3 is 33. Now, it might be tempted to convert this into a mixed number, but this question did say to an improper fraction, so this will be the answer to this question. In this question, we've been given this identity, and we need to work out the values of a, b, and c. We're going to start by expanding the left-hand side. We need to multiply everything that's in the first bracket by everything in the second bracket, so we'll start with x multiplied by x squared, which gives you x cubed. Then x multiplied by 4x, which is 4x squared, and then x multiplied by negative 5x. Then we'll move on to a times x squared, which is ax squared, a times 4x, which is 4ax, and a times negative 5, which is negative 5a. So this is the left-hand side expanded, and this is identically equal to the right-hand side, which is the same as before. What we can do now is compare coefficients. If we see on the left-hand side we have 1x cubed here and 1x cubed here, and they match perfectly, so there's nothing to do there. But then if we go along and look at the x squareds, on the left-hand side we have 4x squared, another ax squared, and on the right-hand side we have bx squared. Since this is an identity, we must have the same amount of x squareds on each side, which means that on the left-hand side where we have 4x squared and ax squared must be the same as bx squared. We can remove the x squareds from this and just write that 4 plus a must equal b. We can do a similar equation if we look at the terms in x. We have negative 5x plus 4ax, and on the right-hand side, cx. So negative 5 plus 4a on the left must equal c from the right. And we can also do the same with the constant terms. So on the left-hand side, we have negative 5a, and on the right-hand side, negative 10. So negative 5a must equal negative 10. Now if we focus on these equations, the one on the right-hand side solves easily. If we divide both sides by negative 5, on the left, negative 5a divided by negative 5 is just a, and on the right, negative 10 divided by negative 5 is positive 2. So we find that a is 2, and we can write this onto our solution. Now if we know that a is 2, we can replace all of the a's in the other equations with 2. So on the left equation where it says 4 plus a equals b, we can replace that a with a 2. So 4 plus 2 equals b, so b must be 6. So we can write that onto our solution. And for the middle of those equations, we can replace a with 2 as well. So instead of 4a, it's 4 lots of 2, which is 8. So negative 5 plus 8 is c. Negative 5 plus 8 is 3, so c must be 3. So the answer to this question is a equals 2, b equals 6, and c equals 3. In this question, we've been told that L is directly proportional to h to the power 2/3. This means there's some constant k for which we can write L as equal to k times h to the power 2/3. We've been given two values in this question. When L is 36, h is 27, so we can substitute those in. So let's replace the L with 36, so 36 equals k multiplied by, and then it's h to the power 2/3, so 27 to the power 2/3. So we have 36 equals k multiplied by, and we're going to work out the value of 27 to the power 2/3. When we have a power 2/3, the 3 on the bottom here tells us we need to do the cube root, and the 2 on the top tells us we need to square it. So we're going to do the cube root of 27, which is 3, and take the result of this and square it. 3 squared is 9. So 27 to the power 2/3 is the same as 9. So we've got k multiplied by 9. K multiplied by 9 is the same as 9k, so we have 36 equals 9k, and we can solve this by dividing both sides by 9. And we can solve this by dividing both sides by 9, and we find the value of k is 4. If we now return to the first thing we wrote down in this question, we know the value of k, so we can write this out once more, but replace the k with a 4. So the equation connecting L and h is L equals 4 lots of h to the power 2/3. In the second part of this question, we need to work out the value of L, given the value of h is 8. We're going to take that formula from the previous part, L equals 4h to the power 2/3, and substitute h for 8. So we have L equals 4 lots of, and it's 8 to the power 2/3. So we have L equals 4 multiplied by, and then we'll work out 8 to the power 2/3. Just like before, we need to do the cube root of this and then square it. The cube root of 8 is equal to 2, and 2 squared is equal to 4. So 8 to the power 2/3 is just 4. So we have L equals 4 times 4, which is 16, and the answer to this question. In this question, we're going to take the left-hand side, so 9 to the power 6 to the power 50, and try and write this as a power of 3. 9 is the same as 3 squared, so if we write this exact same thing out again, but leave out the 9, we can replace the 9 with 3 squared. If we now look at what's inside this larger bracket, 3 squared all to the power 6, we can use the bracket rule here. This says we can just multiply those powers. So this is the same as 3 to the power 12, since 2 times 6 is 12. So here we have 3 to the power 12 all to the power 50. We can use the bracket rule once more to multiply the 12 and the 50, which gives you 600, so this is the same as 3 to the power 600. So if 9 to the power 6 to the power 50 is the same as 3 to the power 600, the value of x in this question must just be 600. In this question, we've been told that x is equal to tan 60 and y is equal to sin 60. These are two exact trig values you need to know. Tan of 60 is the square root of 3, and the sine of 60 is square root 3 over 2. We've been asked to show that 8xy to the power 3 is an integer. So we've got 8 multiplied by x, which is tan 60, but we know that's square root 3, and then multiplied by y cubed, and y is sine 60, which is square root 3 over 2, so square root 3 over 2 cubed. So we just need to show that this is an integer. 8 times square root 3 is just 8 root 3, and then we need to deal with this square root 3 over 2 cubed, which means square root 3 over 2, multiply it by itself and by itself once more, so something like this. We can combine these to one big fraction, so root 3 times root 3 times root 3 over 2 times 2 times 2. So we have 8 root 3, and then this fraction. On the top we have root 3 multiplied by root 3, which is the same as root 9, which is 3. And then we multiply this by another root 3, so 3 root 3. On the bottom it's 2 times 2 times 2, which is 8. We can combine these to one big fraction, so it's 8 root 3 multiplied by 3 root 3, all over 8. On the top here we can multiply these together. We do 8 times 3, which is 24, and root 3 times root 3, which as it was before, is just 3. And on the bottom we have 8. Since 24 divided by 8 is 3, this is just the same as 3 multiplied by 3, which is 9. 9 is an integer, so we've shown that 8xy to the power 3 is an integer. In this question, we've been told that some students have done a maths test and an English test. There are many different ways of approaching this question, but the one I find the easiest is to use a Venn diagram. So we'll have one circle for maths and one circle for English. We're told that 70% of the students pass at least one of the two tests. If they pass at least one, then they could pass one of them, or they could still pass two of them. This section here of the Venn diagram is for the students that pass just the maths test, but they have passed at least one of them. This section is for the students that just passed the English test, but again, that's at least one of them. And the section in the middle here is for those students that pass maths and English. They've passed two of the tests, but that's still included in the students that passed at least one of them. So this shaded area here represents the students that passed at least one of the tests. So this would represent 70% of the students. We're then told that 3/5 of the students passed only one of these tests. 3/5 is the same as 60%, so 60% of the students passed only one of the tests. This means that the two sections marked here, the ones for just passing maths and just passing English, must represent 60%. Now if we know that all three of these regions total 70%, but the one on the left and the right makes a total of 60%, the middle section here must represent 10%. In this question, we've been asked to work out the percentage of the students that passed the English test. So I'm going to label the section for those that only passed English as X. Since the two regions, marked with the green arrows, make a total of 60%, and I've already marked the one for only English as X, the one for only maths must be 60 subtract X. Now I can look at this final statement here. The ratio of the number of students who passed the maths test to the number who passed the English test is 2 to 3. So let's try and write down an algebraic expression for the percentage of students that passed each of those subjects. Let's start with those that passed maths first. This will be any of the students that are in the circle for M. So we've got 60 minus x and 10. So if we add 60 minus x and 10, we could simplify this to get 70 minus x. Then if we do the same idea for English, this will be just the English circle. So this time we have the x and the 10%, so it's just x plus 10. Now we've been told that these are in the ratio 2 to 3. So maths represents 2 parts and English represents 3 parts. So if I take my expression for maths, 70 minus x, and divide it by 2, this will give me 1 part. If I do the same idea for English but divide it by 3, that must also be 1 part. So x plus 10 divided by 3. So these two must be the same. I can now solve this equation by cross-multiplying. If I multiply both sides by 3 and also both sides by 2. On the left-hand side, the 2 will cancel, but I'll need to multiply by 3, so I'll have 3 lots of 70 minus x. On the right side, the 3 will cancel, but I need to multiply by 2 as well, so 2 lots of x plus 10. If I expand these brackets, 3 70s are 210, and 3 times negative x is negative 3x. 2 times x is 2x, and 2 times 10 is 20. Next we can add 3x to both sides. If we add it to the left-hand side, the negative 3x will cancel, so we have 210. And if we add it to the right-hand side, we have 2x plus 3x, which is 5x, and plus 20. Then subtract 20 from both sides. On the left, this gives you 190. And on the right, the 20s cancel, so just 5x. And then divide both sides by 5, and we find the value of x is 38. So we can update our Venn diagram now we know the value of x. X is 38%. And also if we do 60 minus x, that's 60 minus 38, so that section for maths only would be 22. In this question we were asked to find the percentage of students that pass the English test, so that's both of these percentages here. 10% plus 38% is 48%. In this question we have a compound shape and it's made from a triangle and a sector, and we've been asked to work out the value of the perimeter. We're going to start by looking at this triangle here, so triangle ABO. We're going to find the missing lengths of OA and OB. To do this, we're going to use trigonometry since it's a right-angled triangle. So we can label the hypotenuse, which is the line from B to O, and the opposite, which is the line from A to O, and the adjacent is the line from A to B. Let's try and find the hypotenuse first, and we can do this using cos. So cos of 60 is equal to the adjacent, which is 6, divided by the hypotenuse, which we don't know, so we'll call it h. Cos of 60 is an exact value you should know, is equal to 1/2. So 1/2 is equal to 6 over h. If 1/2 is equal to 6 over h, then h must be 12, since 6 over 12 is the same as 1/2. So we find that h is equal to 12, and we can add this to our diagram. Now let's also find the opposite. To do this we can use tan. Tan of 60 will be equal to the opposite, which we don't know, so we'll call that O, divided by the adjacent, which is 6. If you multiply both sides of this by 6, you find that O is equal to 6 tan 60. Tan 60 is one of those values you should know again, it's square root 3. So O will equal 6 times square root 3, or 6 root 3. Let's put this onto our diagram as well. Now let's put both of those new lengths, the 12 and the 6 root 3, onto the main diagram with the sector, so 12 and 6 root 3. The next thing we need to do is label the length of OC. Since OBC is a sector, we know that OB and OC are both the radius of that sector. Since OB is equal to 12, OC must also be equal to 12. Now to find the perimeter of this shape, we want the total distance around the outside, and there's only one length that's missing. That's this arc here from B to C. So we're going to take a closer look at this sector. To work out the length of an arc, we need the formula theta over 360, where theta is the angle of the sector, multiplied by pi, multiplied by the diameter. We haven't got the angle for that sector yet, but we can work it out quite easily. If we look at the triangle first of all, there are 180 degrees in the triangle, and we know two of the angles, the 90 and the 60, which means this missing angle here must be 30. Then we know that AOC is a straight line because it tells us in the question. The angles on a straight line also add up to 180, so the missing angle here inside the sector must be 150. So we know the value of theta is actually 150. We also need the diameter for this question, which is twice as long as the radius. The radius of the sector was 12, so the diameter will be double 12, which is 24. Now we don't have a calculator for this question, so we need to try and work this out. If we look at the fraction, we can divide both of these by 30 to simplify it. 150 divided by 30 is 5, and 360 divided by 30 is 12. And then if we multiply this by pi and 24, that's just the same as multiplying by 24 pi. To multiply these together, we can just multiply 5 and 24, which gives you 120, so on the top we have 120 pi, and on the bottom 12. 120 divided by 12 is 10, so this is the same as 10 pi. So let's update our diagram with the length from B to C, which is 10 pi. We can now find the perimeter of this compound shape by adding together its lengths. So I'm going to start with B to A, which is 6, and then add to this A to O, which is 6 root 3, and then O to C, which is 12, and then C all the way back round to B along the arc, which is 10 pi. I need to write this in the form given in the question, a pi plus b root 3 plus c. So we've got a pi, which is our 10 pi, and we've got the b root 3, which is 6 root 3, and this constant term at the end must come from 6 plus 12, which is 18. So the answer is 10 pi plus 6 root 3 plus 18. In this question, we need to work out fg of 0.5. This could also be written as f of g of 0.5. So we're going to work out g of 0.5 first, and then put this into the f function. So let's do g of 0.5. Well, the g function is given to us in the question, it's 3 minus 2x. So we just need to replace that x with 0.5. So it's 3, subtract 2 lots of 0.5. Two 0.5s are just 1, so it's 3 take away 1, which is 2. So now we know the value of g of 5, which is 2, we can use this as the input to the f function. So we need to do f of 2. We're also given the f function in the question, it's 9 minus 4x over x, so we just need to write this out again, but replace the x with a 2. So it's 9 minus 4 lots of 2 divided by 2. 4 lots of 2 is just 8, so it's 9 minus 8 over 2, and 9 minus 8 is 1, so it's 1 over 2, which is a half, or 0.5. In the second part of the question, we need to work out f of the square root of 3. To do this, we're going to take the f function and replace the x with the square root of 3. So f of root 3 equals 9 minus 4 lots of square root 3 divided by square root 3. We need to give our answer in the form a root 3 plus b, so we need to rationalise the denominator here. To do this, we're going to multiply the top and bottom of this by square root 3. On the top, this means we have 9 minus 4 root 3 multiplied by root 3, which is probably easier to write as root 3 lots of 9 minus 4 root 3. On the bottom, we just have root 3 multiplied by root 3, which is the same as 3. So we have a fraction all over 3, and we can expand this bracket on the top. If we do root 3 multiplied by 9, that's just 9 root 3, and then root 3 multiplied by negative 4 root 3, here we multiply the root 3's together, which gives you 3, and then multiply this by negative 4, so negative 12. We can now just divide both parts of this by 3. 9 root 3 divided by 3 is 3 root 3, and negative 12 divided by 3 is negative 4. So the answer to this question is 3 root 3 minus 4, which matches the form given in the question. A would be equal to 3, and b is negative 4. In the final part of this question, we need to solve an equation. On the left-hand side of this equation, we have the inverse function of f, so we're going to need to work that out first. To do this, we write out the f function, but replace the f of x with a y. We then turn all of the y's into x's and all of the x's into y's. So instead of y equals, it will be x equals, and both of the x's on the right-hand side will turn into y's. We now need to rearrange this to make y the subject. We'll start by multiplying both sides by y. If you multiply the left by y, you get xy, and if you multiply the right by y, the y's will cancel, so it's 9 minus 4y. Then if we add 4y to both sides, on the left we'll have xy plus 4y, and on the right the negative 4y will cancel, so it's just 9. Now that we have all of the terms with y together on the left-hand side, we can factorise. So this will be y, then a bracket. Inside the bracket I'll need an x to get xy, and I'll need a positive 4 to get 4y. And this must equal 9. We can then divide both sides by x plus 4, and this will give us y equals 9 over x plus 4. If we replace the y with the inverse function of f, we then have f inverse of x is equal to 9 over x plus 4. So now that we've worked out the inverse function, we can return to the equation. The equation said the inverse function of f is equal to g of x. We know g of x, that's given in the question, so we can write the inverse function of f, which is 9 over x plus 4, equals g of x, which is 3 minus 2x. To solve this equation, we'll multiply both sides by x plus 4 first. If we multiply the left by x plus 4, we get 9, and if we multiply the right by x plus 4, we've got 3 minus 2x, and this needs to be multiplied by x plus 4. We can leave the left-hand side as 9 and expand these brackets on the right-hand side. We do 3 times x, which is 3x, 3 times positive 4, which is positive 12, negative 2x times x, which is negative 2x squared, and negative 2x times positive 4, which is negative 8x. We can simplify the x terms here. We've got 3x and also subtract 8x, which will be negative 5x. And then we want to get all of the terms on the same side, and I'm going to go for the left-hand side. So I'm going to add 2x squared to both sides. This will give me a positive 2x squared on the left, Then I'm going to add 5x to both sides, this will give me plus 5x, and then subtract 12 from both sides. On the left I have 9 and I subtract 12, that's negative 3, and all of the terms on the right hand side will have cancelled, so I get 0. This quadratic will factorise, it's 2x minus 1 and x plus 3 equals 0, which gives me two solutions. Either 2x minus 1 equals 0, and if we add 1 to both sides we get 2x equals 1, and then divide by 2, we get x equals a half. Or x plus 3 equals 0, and if we subtract 3 from both sides we find that x is negative 3. So there are two solutions, x equals 0.5 and x equals negative 3. Thank you for watching this video, I hope you found it useful. I've put some suggested grade boundaries here, but we won't know the real grade boundaries until after the paper's been done. These are just based on previous years to give you a rough idea. Subscribe to my channel if you don't want to miss out on future videos, and if you did find this useful, please like, leave me a comment, or share this video with other people.